Alright, let's dance. You know what, I might hit a...
Calculus is hard because it is different. It introduces
Calculus Zoom
concepts
class after
such
this
as
if
the
I
limit,
can,
the
for
derivative,
kids.
and the integral. These are novel concepts that appear completely unintuitive and hard to grasp. When students don't
I'll show you why in a
understand
second.
the
I managed to get to like the
their
first
applications
example.
are next to impossible.
The very first thing he
So,
gives these
to
5th graders
calculus,
is
we
infinity.
first must reinforce the concepts that are fundamental to its foundation.
Like, these kids don't have a purpose. They're not smart enough. No
I
offense to
believe
the
the key
kids,
to
but they're not smart enough to
understanding
understand,
calculus
oh, I
lies in
need
teaching these
numbers at the
concepts.
decimal point. Like,
The algebra and
without
complicated
terminals
math
to
that
work in the
trips
first
students
place,
up
they
can
wouldn't
be
get
learned
to
in time.
infinity.
But a student who never grasps
It's like,
the fundamental
well, I'll show
ideas
you
of
what I'm talking
calculus
about here in a
can
minute,
never
because
succeed.
this
So,
is what they did.
let's
This
take a
is from
step
4
back
years
from
ago.
everything we know about math and
Which
try
is,
to learn
that's why I
calculus
want to
in a
hit the
whole
Zoom
new
class
way.
after this, see if I can find something a little bit more local to a kid's class, given the pandemic, because then I could see exactly what they were working on.
So infinity is really cool because
Yeah,
it allows
right.
us to talk about things that
Well,
are
infinity's
either
in
really
this class.
big
The difference
or
between
really
you
small.
and you, kid, is infinity.
has this reputation of being known as the biggest number. Have you guys heard
Between
of that
you and
before?
you, infinity. Not 1,
Yes.
not 2, not 5 steps, not your parents, but to graph that would be infinity.
Not. Yes, you're correct. If I asked you guys to count the numbers,
Why don't we start with
between
something a
1
little
and
bit
2,
more practical
1.1 is slightly
in terms
bigger
of it.
than
Well,
1,
oh, that's the
right?
problem with
And
finding
it definitely is between 1 and 2.
teacher's
We
level,
all agree?
teacher's union level. It's
So
like,
right
what
now,
can we
we have
agree
one
with
number
from
between 1
New
and 2.
York to California,
1.11
Russia to
is
China,
also
what
between 1 and
infinity
2,
is?
right?
It's got to be
It's a little
something
bit
practical
bigger
to
than
the
1.1,
kids.
right?
Every one of them's got
So
to
now we have two
understand
numbers
this,
that are
and
definitely
it's got to be
between
something
1
we
and
can
2.
break down into
1.111.
parts. What do you
This
mean?
is also between 1 and 2.
Well, let's
So,
look at a
if we
train
keep
traveling down the
adding
tracks in this
ones,
direction
that's what
and
the
then this
dot, 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 dot
direction.
means over there.
This one
That
traveling
means we
at
just keep
5
adding
miles
one
an
on to
hour,
then
this
sum
one
it forever.
traveling at
And every
15
single
miles an
time
hour.
we add one
But
on,
I'm not going to give
the
you a
number gets a little
distance.
bit bigger, right?
That
So
distance is
it's
infinity.
a unique number. It's a different number.
It's a unique
that's between 1
number.
and 2
It's
every
got
single time
X,
we do
Y, and
this.
Z to it. What do you mean?
And
It's
if
like I
we
could
keep
change
counting these numbers,
the
as in
distance
how many
between
numbers
them
are
to
between 1
be
and 2,
10 miles.
we'll
I could
never
do
end.
it to be 5
That
miles.
is infinity.
I could be doing it right
Infinity
close together,
is
and they're
a
moving this
concept.
far from each other with no momentum.
And this is crucial to understanding not just infinity, but also for calculus.
And you're trying to get this
So,
kid to go,
now
well,
with
I'm
that,
actually
let's
not
talk
1 year,
about
I'm not
1
actually
over
10
infinity.
years old,
If
I'm
I have
10
1
years
over 2,
old and a
have
half,
this one
still
pizza cut in
counting
half,
into
and this red
tomorrow,
right here
into
is
something
the
different.
amount of my
And
one
to
slice.
graph
Do you
that,
agree?
you have to do that forever.
So now let's go to
Until
1
you're
over
dead.
3. We have this one pizza, and we divide
And we
it
don't
into
know where
3
that
equal
is.
slices. This
Maybe
red
graphing
slice
will help you get there a
is the
little bit
amount
faster
of
to
one
figure out your
slice.
Lucy.
And now if we divide it into 4,
But
what do we notice? Gets even smaller, right? So when we have 1 over 5, it's a little bit smaller. Okay.
and he's going through the
1 over
roster
6,
of a
1 over
matrix.
15.
I'm kind of like that.
Let's look at 1 over 80.
But do these kids know what any
What
pie
would
chart
happen
equals short of their lunch?
If we go to 1 over
It's like,
infinity,
let's
the
go in that
question
notebook.
Is it equal to 0?
Let's go in
So
your
remember
lunch line, your tray.
that
You've
infinity is
eaten
not
how
a
much
number.
percentage of the
So
food?
1 over infinity
That's an infinity.
doesn't
It's like you left the
represent
macaroni and
anything.
cheese on
Remember,
the
we had to have
table
a
or
number at
on
the
the
bottom of this thing, right?
in that little tray right there, but you ate all your
divide
macaroni.
into a certain
But you're
number
not.
of slices.
You don't
And
understand
if we
calculus,
divide by
kid.
infinity, to me,
That's
that means
bullshit.
nothing. But
Take some
what does
time to
that mean
actually
about our pizza
practically
slice?
teach these kids
Well,
something
we said it's
that's
not equal to 0.
useful.
But what we can say is that 1 over infinity
Is X?
goes to 0.
It goes to
When
0.
we increase that number on the bottom, our
Why
slice-
do you
our
bother
slice
teaching
gets
these
smaller
kids
and smaller
this
and
stuff?
smaller. And if we keep
It's
doing
not
that forever,
practical. Let's
and we
get them
keep
some
adding
jobs
1
in the
to that
area.
bottom
Let's
number,
say, here's a
our slice
graphing
is
way to
getting
do things.
closer
Where
and
real
closer
numbers
and
where you can actually
closer
find. You count
to
those
being
numbers
nothing.
out.
But it's never
How many
equal to
things
nothing.
that are
What this is
made,
called, and
harvested.
this is
Go to the
important,
orchard for sure. There's a
This is
tree. It's got
infinitely
apples
small.
on it. It works. No. Somebody got fancy
1
inside
over
here
infinity
about
is
some
an
dumb
infinitely
shit.
Small number.
Percentageably
Just
out
like
of the year.
infinity is an
How
infinitely
long are
large number.
apples
Let's
edible?
move on to something that I know you're
How
familiar with, area.
the,
I wanna talk
the
to you
distance
guys
off
about
of
an
all these
interesting
points
way
in the
to take
tree by
area.
the measurement. And let's say
So,
it's
let's
from
say
here
we're trying
and
to
it falls down.
calculate the
What, you
area
think
of a
infinity is
triangle. A
easier?
way that we might be able to do it is by taking something whose area that we do know and filling our triangle with it. So let's say we have our quarters stacked up like this.
Yeah, Roman inches. I got this many
we wanna
links on my
say, what
hand.
is the
Well, quarters
area
are
of a
actually good. I don't
triangle
mind quarters to
that has this
determine
shape?
area.
Well,
But they're
let's
not
count the
squares.
quarters and say
It's like you're still going to get an approximation between this. If it's a 1x1 square and I'm trying to figure out the area of this board right here, I can close it off. And then I can put arbitrary shapes inside of there. Now maybe, just maybe, if I had to figure out the area of triangles inside here, you're going to get to actually some stuff where it's going to get a little extra runoff and run down, but I could say, well, you know what, there's still a gap here, and let's say one of those gaps equals roughly one of those gaps, and that'll give me an approximation of that area. Now, why don't you just make them carpenters? You can get a concrete pour in there. It's practical, it's sensible. How do you find the area of a triangle? You go get a tape measure.
Now we have a lot more columns, right?
You know, this is ridiculous to make these kids factor some value like this that's an arbitrary distance like that. Because I don't even do that. It's like, well, how do I figure out this 45 on the stock market by the area of fucking quarters? It's bullshit. How do I figure out the area of the grade of these kids? Well, they all got an F inside of here. The area is they can't handle the math. That's where the area is. They can't handle the math teacher. Some arbitrary number. And look, we just blew through all kinds of stuff. There is no fundamental test where you would see some situation inside here where it's like, oh, I need quarters, and now quarters are going to show up on the test. How many quarters does it take to come in and fill this in here? This is horseshit. Fuck your critical theory. Go into algebra class.
And if we fill this triangle up, it almost looks perfect. We know that there's a little bit of space inside.
And not only that, turn this damn thing around so 0 is always in this corner here, not straight up here. Give us the X and Y axis inside here instead of making us guess it and do some arbitrary backwards line over here, would you please? Right hand rule. We're not free thinking in kids' classes, so the last math problem that they had was this way, and this one is this way, and you're trying to hide some damn fancy magic about whatever bullshit this is going to lead to, because there's a lot of them. And they still all would go on that other side XY rule, not 0, try to figure out what X is inside of here by giving them Y and C. It's like, well, what processes I'm missing? Because there's, when you go to work, should it be in a computer programmer? Good God. That's what you're trying to make them? Then why the fuck are you using quarters? I'd rip this guy's heart out and feed it to him.